great introduction, Said. I feel like I don't have to introduce myself anymore. Today's talk will be about how human-computer interaction researcher is looking at this thing, hype called virtual reality and augmented reality, and what are the research issues, what I can contribute to, other than enhancing a FOV of a optical system, or enhancing the latency of, reducing the latency of the rendering pipeline. What is the interaction issues of human-computer interaction in VR and AR? So this is what I'm doing. I am doing a bunch of user interface stuff, designing, studying, developing computer-supported cooperative work system, educational technologies, putting into a context of a classroom, evaluating it with a real student, real instructor, and some of a VR-AR interaction technique. So I'm pretty much clearly human-computer interaction researcher in the spectrum, right? Computing. What is human-computer interaction? Anybody know what HCI is, or who just learned about HCI by looking at this slide? Yes, human-computer interaction is a field of study that tries to understand how and why human interact with computer. And we sometimes create tools for better interacting with computer. And some other people say, expanding the notion of interaction, maybe you want to interacting with others through the computer, via computer, and that can also, as a communication technology, fall into the interest of human-computer interaction research. Then when a human-computer interaction researcher like me, especially me in this talk, because a lot of this talk's content is about the perspective, not about fact, but the way I see with a human-computer interaction lens, especially based on my personal history of building myself as a human-computer interaction researcher, and a type of human-computer interaction researcher. So it's going to be about perspective about how we're going to see this thing like human-computer interaction and VR, AR, and make comparison and contrast between those two. Question, all those differences only about 2D and 3D, or display screen versus HMD display, right? What are the core differences? As I see this thing like HCI, this thing like AR and VR. So I talked about this is all about lenses, how we draw on different lenses. And it's more about the epistemological standpoint in terms of making different types of the research contribution. One stark difference that I noticed from the discussion around VR and AR is that how can VR AR researcher in the field or community like VRST or IEEE VR or transaction in computer graphics, people looking at AR and VR is different from how human-computer interaction researchers looking at AR, VR, and contrasting those two, right? Is AR a VR with real world? Is that the thing, right? So let me start from that point, because that's the most fundamental issues about defining and talking about VR and AR. And when it comes to the VR and AR community, this is really canonical description about how VR and AR can be fit into one conceptual framework. So you can see the continuum of kind of reality and virtuality. So one far end, you can see real environment. The other is the totally virtual environment. And as the reality and virtuality mixes in together in different way, it could be you're pulling up the computational object, like artifacts, virtually on real world, which is going to be augmented reality, or vice versa, then it's going to be augmented virtuality. So VR AR traditionally tends to be put into a one continuum as a quite different only in how much the reality can kicks in. However, one school of thought in human computer interaction, which is called ubiquitous computing, see it really differently. This field of ubiquitous computing has been pioneered by Mark Weiser, who was a zero-part researcher, actively worked on the 80s and 90s, and coined this notion of the ubiquitous computing. So in his positional paper published to the Scientific American on 91st, the computer for the 21st century, he showed this vision. The most profound technologies are those that disappears to the background. And we should allow the computer themselves to vanish into the background so that we cannot even perceive that. And the analogy he makes to this computational technology, to the traditional one, is that the ideal computational technology should be like pen and paper, writing technology, which is the very fundamental and long-standing information technology we have used so far. What are the benefits of pen and paper? They are ubiquitous, they're everywhere. We don't even perceive pen and paper as a technology. But if you think about it, this is a super cool technical pieces. The way papers are manufactured into thin form factor, the size, affordances that it allows, and color, and different lines that you can put on, different types of design. And look at this pen, different types of pens, and the way you can use it. This is a designed craft. But we don't feel that because this is so naturally, this is so well designed in a way that it can be just used as is, right? So, his points, at that time where all the computer was big chunk of machine, or at least a desktop computer, there was no mobile or no tablet computer. At the time, he coined this concept of the ubiquity, where computing should be feel like that, feel like there's no technologies there. It should not be obtrusive as desktop computer. And he put a core notion of embodied virtuality as the antithesis of the virtual reality, which was also at the hype at the time. So, anybody know the Nintendo Virtual Boy? The gaming machine has a big VR screen. It was a precursor of the Oculus Rift or HTC Vive at 80s and 90s. There was virtual reality hype at the time, but it somehow went down because of the many different reasons, especially because it didn't find a killer application. But the thing is that there was a hype of virtual reality, and there's a lot of discussion about what this VR thing is compared to other rudimentary field of human-computer interaction. And Mark Weiser, with the notion of ubiquitous computing, presented the notion of the embodied virtuality too. Embodied virtuality means that these computational things should be embodied into the field of context where people actually do the work. So it is now really obvious for us when we are doing work, we have tablet computer. When we do design work, we have a stylus and iPad. And we are going out for lunch, find out a nice restaurant using Yelp, we pull up a mobile phone. But at the time, there was the only computation available on the desktop computer at a specific place, right? So even this vision was really groundbreaking at the time. So with his colleague at Xerox PARC, he came up with these ideas of the badges, tabs, pads, and even boards, which commensurate to our mobile device, smartphones, iPads, or maybe wall-top computer or tablet computers these days, which is really amazing. And the way he put these devices and inventiveness of these tools is that these are embodying the virtuality into the people's working context. That's the core notion here. And how that is being contrasted with the virtual reality, right? Why he was kind of putting it as an antithesis of the virtual reality. Because when you wear the device at the time, and also now, if it is an augmented reality thing, it cuts off your senses, your awareness about external world. You are purely in the computation. So it's totally different. Embodied virtuality puts computation into the context. But as you're wearing the virtual reality glasses, doing interaction, you're not in the work context anymore, which matters a lot. So, for the sake of time being, we can skip the more detailed concept about the embodied virtuality. But it doesn't only mean that VR AR field was totally oblivious about such a notion. They were aware of the importance of the context, real context, and they put it as a part of their measure it hasn't been totally explicated in the context of the work, right? Why? I'm gonna cover that very soon. But before that, there's another point that I have to bring up with the notion of the ubiquitous computing. It's the concept of transparency. What does it mean that computers being transparent? It doesn't mean that a display is being transparent and you can look through things around. No. The concept of transparency in ubiquitous computing is that the computing doesn't catches people's attention. The interface is not catching attention, but it is the task that is catching the attention of the people. As we are writing on paper using pen, we don't feel that we are grasping the pen. So this notion of transparency not only describes this interactional aspect of a physical interaction aspect of transparency. It also means the context of your task itself. For example, Bill Buxton come up with a really great example of transparency, where when you read Kindle book, you read through pages like very, and then when you switch the devices and you're now lying in the bed and try to read a Kindle book using your smartphone, switching the devices, but when you pull up the Kindle book, it somehow synced the page that you have written so far and then moved the page to the right position right away, right? So you don't have to care about where I was at. You're just focusing on what you're reading, right? That's another type of the transparency we want from the ubiquitous computing, right? So we don't want to feel interface. We want to make it disappear. And in line of that idea, I come up with this new type of ebook interfaces where you can read the book in augmented reality setting. So the concept is like this. This is the work that I have done in 2012. So you can see me wearing a AR glass. It's a see-through HMD glass. So you can see real world together with augmented images. But what I want to do is reading ebooks, like pulling a book and then navigating the pages. But the issue is I don't want to wave my hands in the air like this every time I turn the pages, right? Because that's too fatiguesome. There's even the name of that fatigue. It's a gorilla arm problem. You don't want to be like Street Fighter for reading book, especially when you reading through the book for the multiple pages. What I come up with an idea is that you can use smartphone as a tangible prop for navigating the book, because you can touch and use motion gesture on the smartphone. So you can see that ebook is augmented on a smartphone. You can zoom in and out. You can put your finger, you can slide the book and then flip through, just like real book. And see what happens here. I put a finger in the middle between. I'm gonna show you again. I can put a finger here. I put a finger on the page just like I do with a real book, and then you can flip through to the next page to find something else and check something here. Okay, I see that I can get back to that point right away, like this. And you can see how zooming and zooming out is so natural, as if you're reading the real book, right? And this technology, this patent of this technology has been sold to Samsung at $250,000 this year. So this is not just a toy thing, but it matters because people try to do with, for example, like Galaxy Gear and Galaxy smartphone, maybe, I don't know, but they're trying to do something with this type of interaction. All right, so because I don't want to be the only one talking here, I want to do a little design brainstorming session here for about 5 minutes, right? So I want you to be grouped. I think we are already sit together in a beautiful way. If you feel like you're so lonely, only 2 or 1 people, you can move around. But I want you to discuss in group for like 2 or 3 minutes about what other affordances, what other interaction that you do with real book can be transferred to my like augmented reality system, right? For example, it can be, I don't know, writing or some other type of the navigation, right? And then let's talk about it for like 1 or 2 minutes, right? Can you do discussion right now? Let's start. It's really heated discussion. I want all of you as my research collaborator. So anybody who are proud of our inventive ideas, so want to present mine? No? Then I want to start from maybe this group.
Well, I thought that in a real book you can't like rip out pages, so it would be cool if you could just like take out a page and just like have it somewhere in the air, so you could always like look at it if you're like writing something and you need to reference different places in the book instead of flipping through it. You could just be on multiple spaces in the air.
That's so cool. Yes. The major benefit of 3D is that you have the infinite FOV and working spaces, right? So you can use that as an anchor point where you can bookmark it and then lay out all the information so you can refer it later on. Awesome. Yeah. Anybody wanna add up, or I can point to this group, which is large group. Yeah. Yeah.
We were thinking that using like something electronic would make it really easy to interface with the internet. So if you wanted to like look something up, or if you wanted to translate something, that it gets done much faster than you have to actually switch to like go from a physical book to your phone or something like that.
Right. Putting more like interfacing more naturally with the online data, such as web pages, email. Why can those feel like a real book, more with better visibility, better interaction, right? Great idea. All right, one more idea, and we're gonna move on. Over there.
No, lately I hear so many new research reports from Japan and China, which are only available in Chinese and Japanese. But if they could instantly translate into English, they will be available for all UBC students.
Interesting, yeah. More cross-cultural issues, right? That maybe in this context, we can put somebody who are versed in certain language into a presence, such as avatar, and let them talk to me as we are reading the book. I don't know. Could be possible. Interesting. But there's an emerging theme, right? We want more natural interaction that we brought up from a real experience, and that has some benefits as is, like ripping things off or writing on the pages, right? So there are a lot UI work to do. So I want to zoom out and then talk about more different types of the human-computer interaction by taking a more retroactive and chronological historical look on the types of the human-computer interaction. There has been people are saying in HCI, there has been 3 different types or waves of human-computer interaction researches. It's like a trend of HCI that has decade-long time phases. The first wave was started around 50s, 60s, and then still there are lots of active research going under this first wave theoretical underpinning. So those are more focused on human factors like how performance are changing, and also based on the cognitivism theories, where you are taking analytical perspective about people's task, where there's a big thing that you have to do something on the computer, and then it breaks down tasks into micro tasks such as typing, clicking a button, pointing and click, right? And create a model of a more cognitive model and maybe mechanical model of those micro tasks so that you can measure the performance and enhance the performance by measuring those. That's why this is so famous human processing model figure in HCI, where you see this human, just like robot, has different modules in the cognitive module. And there's even working memory that has the like fading time, like half-life time. So the one of the major contribution of those works are Fitzlow, I can see. Anybody know what Fitzlow is? It's a predictive model that measures the time completion of the selection task using mouse or pen, depending on the size of the target and the distance from this this really simple model where you can predict that selection test is going to be more faster if you're closer to the target and the target is larger, right? It's obvious, larger, easy to select, right? But having that idea, it implies a lot for how we have to shape the button, what type of selection device we have to use, because at the time, selection test was so important. But in the second wave, people started to step up to a more higher level, in the contextual level. And Mark Weiser's ubiquitous computing was at the beginning of the second phase, second wave changes. People start to focus more on the workplace itself. As you can see here, this is one study had done in the NASA about how people use display differently in a group setting. And when it comes to real work setting, how fast you can type, how fast you can select a button might not matter a lot. Maybe there can be more nuanced, fluid, and complicated matter that's more important in the work process itself. Such as, there's a social hierarchy where you have a boss, and for example, where you have for example, in a classroom where you have a professor. I'm a student, I want to submit a paper, but there's a social tension, such as I want to represent myself better to be a better student, and I want to submit a assignment in a way that doesn't hurt my boss's feeling, right? So those complicated social contexts should kick in, and the nuances and fluidity of the social context cannot be grasped by the technical feasibility of the digital system. And how can we bridge those gaps or close those gaps as far as possible? That was the major issue of human-computer interaction in the second wave. So they talk a lot about how people collaborate in a different setting. What are the social, physical, or task context in the digital work? So that was around 1980 to still current. There has been development of those schools of thought. In the third wave, which is more modern approach, is not focusing on the work itself. Before then, it was all about the task, all about performance, all about productivity. But now people start to use technology, computation for something else, such as their life, emotion, love, engagement. And computation is the baseline infrastructure of every part of our life. So it is more important, these people think that it is more important to reflect on the way computation is being handled in our daily lives. So now, computation, HCI, move out from the office setting and then penetrated into our everyday lives. And they're doing interesting design work, such as creating a digital artifact that is not usable, such as this camera, where you have to break the camera to have access to the picture that you have taken. Or, here's the camera that you cannot even take out the photo. You can only take a look at the photo that you have taken through this camera. Why they're building this? Because they want to put a critical argument about technicality or some more high-level concepts, such as ownership, agency, control. I don't know. It's really, really complicated, which space of study. Especially SFU with the pioneers including Will Autumn and Clara Neufstetter is doing a great job in this field as well. All right. What I want to make claim here compared to the VR AR research is that I want to make a little bit of grain of salt arguments that AR VR hasn't really been used to the real tasks in the world. Real productive tasks. There has been some examples, but not as extensively as other computations that has been handled in human-computer interaction. Not as, for example, Microsoft Word, not as Google Doc, not as word processing spreadsheet, right? That's why VR AR people are still talking about killer application. And it is really easy to, it is natural to talk about the first wave topics, such as how quickly, how accurately you can select a 3D object in VR AR environment, right? So that study has been really well developed here. And some other VR AR field has been discussing about use of the VR, applications of VR in different way. And actually VR AR are great media or communication platform that make people think, make people reflect about their own self. There are studies where you're in the VR field and it displays you as a person avatar with a different race, different gender. And that study is especially for this type of third wave fashion idea. Like, how could we make people think about yourself through the medium of the computation, which is VR AR in this sense, right? But what I see, totally my perspective now, is lacking in VR AR study. It's a little bit of this. There has been some discussion about how it can be used in the work context, but not as extensively as computer-supported cooperative work as in human-computer interaction. One argument I want to make is especially about the lack of interest in asynchronous collaboration in AR/VR. So here, I want to tell you the differences between the synchronous and asynchronous collaboration tool. So synchronous tool means that you can expect other people's response in the collaboration system right away, just like chat or video conferencing. Especially in video conferencing, you're just looking at other people face to face, and it happens at the same time in synchrony, right? But in asynchronous setting, just like email, textual comment on Google Doc, Word, or Git submission or like pushback, those are all asynchronous. You can work alone, and then you can just move on, and then you're gonna merge your content later on, right? So big differences, but there has been extensive study about asynchronous and synchronous tools in human-computer interaction. Why asynchronous tools are efficient for some context. Everybody clear about the differences between asynchronicity and synchronicity, right? Chat can be a little confusing, right? Because you can leave a message and then just leave it like there. Sometimes, yes, it's been used as asynchronous media, but the way people use it is synchronous because you're expecting to get the response right away. Okay, just to clarify. All right, why asynchronous collaboration is efficient and useful, or even necessary sometimes, right? The best way to formalize this question would be, have you ever sent an email to the person who is sitting next to you, right? You actively chose an asynchronous media for its own benefit, even though asynchronous face-to-face meeting is possible, right? Why do you do that? Researchers have studied a lot in the work context, real work context in HCI, and they found out that asynchronous media gives you a flexible and independent work. For example, every time when you revise your thesis paper, you don't want your advisor to sit next to you. You want to work alone and then formulate some work and then asynchronously revise it by your advisor later on, right? And second, it gives more time to reflect on individual's work, right? Because you're working alone, then you can more deeply get into the topic. And it's the same for even, for example, like email discussion, right? You tend to use more longer sentences. You tend to send more sentences, to think more about others' message, and it takes more time to discuss, but sometimes it enables you to go deeper into the topic, not only the surface scratching thing. But yes, face-to-face is important when you try to handle more nuanced or a social issue needs a presence of somebody else. Finally, asynchronous messages are recorded, right? Such as email or voicemail, I don't know. So you can revise the content before you send it, and you can review it after you get it, right? So it all tied connect to different benefits, but there is context where asynchronous collaboration is crucial all the time. Then, what it means that we need VR AR asynchronous. We need asynchronous system in AR VR. Do everybody know what this is from? This is very famous Princess Leia's holographic message in Star Wars, and this asynchronous message, asynchronous communication media concept has been well presented in many different movies, such as Minority Reports. There has been a scene where the major actor reflecting on a recorded images of one's daughter, right? And this is the other one. And also, recent technical advancements is making it possible, technically feasible to implement such system where you can record.
Hi, today we're going to show you an exciting new technology that will fundamentally change the way that we communicate in the future.
All right.
Imagine being able to. I'm coming home very soon.
So this person is wearing a AR glass, and his daughter is performing in totally different spaces.
You can only hear me.
Right.
You can't see
This
me.
is now synchronous, but interesting happened here.
Think back that entire
Happens
section.
here. Now
this
one
is
can
almost like reversing through time.
replay recorded
If I wear my
message
HoloLens device,
later on and can
it's almost
review
like
it.
walking into a living memory that I can see through another pair of eyes from all the. Imagine being able to teleport to
And
any
you can even
place
resize
with
it.
anyone at any time.
So technically, yes, you can do a asynchronous communication in AR, VR that way. You can record all the performance, the way you speak, the way you gesture, the way you manipulate the object. All can be recorded and then sent to the other people, right? My question is, would that be enough? Would that be just good enough to be used? And that's the same question as, are you happy with your voicemail application in your smartphone? Anybody who happy with using voicemail? And we know that this is a broken technology and there needs to be some UI innovation to make it better. So let me go for a detail about why asynchronous tools are broken and how we can fix it. And it's an extension to a VR AR study in the interaction side. So we need a multimodal communication cues for interacting better with other people, such as speech, gesture, and pen writing to convey nuances, emotion, and our graphical concept. However, when it comes to educational context, we don't have such capability in our existing technology. Everything is textual, especially when it comes to asynchronous technology. Think about it, email, Google Doc. Other than the voicemail that many other people don't enjoy, everything is textual. Then how can you bring in such rich modality into our educational context? So this is part of my research. This is work called Rich Review. And I built this system, a multimodal annotation system that combines the power of speech, gesture, and inking together to enhance the communication capability of document annotation.
I think you can improve this paradigm by fleshing out a little more details about these references, especially in relation with the notion of data annotations and visual representations to connect these three paragraphs cohesively.
All right, that's a recorded message on a textual page, and it's replay.
You can improve this paragraph by fleshing out a little more details about these references, especially in relation with the notion of data annotations and visual representations to connect these three paragraphs cohesively.
Can you see how recorded voice message, gesture can be combined together to deliver a presence of somebody as if somebody's talking next to you over a pen and paper, over a written text. So that's the power of kind of asynchronous, rich multimodal asynchronous media, which can be brought into a VR AR setting as well. So you can simply imagine use of the holoportation demo from Microsoft, and then it's the same level of interaction, right? Only the difference is the type of fidelity of interaction, right? But as I'm deploying this system to the real classroom, I found that there are three core challenges of those interfaces. The first one was the browsing. And this is the one that everybody knows about the voicemail interaction issue. So when you get a voicemail recorded message, it's really painful to listen through entire voice from the beginning to the end, right? And it is also hard to know which content is where. So you don't know which part of the bar you have to jump in, right? So those are serious issues in terms of a recipient side user interface. How can you solve that? In Rich Review, we used a rich navigational cues to solve that problem. So what you can see is that every single visual element in Rich Review are indexable, which means that you can tap to replay the correct time where the gesture or waveform has been recorded. And then you can replay from that side right away by tapping it. So it really helps you find out where your speech starts and where your gesture starts, right? So you can hear the speech that I have recorded while making the gesture, which really helps you navigate through the audio much better than bar navigation. And when we deployed it to a classroom, interestingly, students like Rich Review even better than office hour meeting, which is real face-to-face meeting. Why? Because they can replay. When they're meeting with the instructor face-to-face, they are in the pressure that they might lose something. They don't want to ask back to the instructor because they want to present themselves to be more smart and competent. And this one, with the help of the replayability, more easy replay, really help them to like and prefer Rich Review better. The second issue is about editing. Now think about not the recipient, but the one who are recording the message. Then it is really hard to edit the message because now you have recorded everything as a one stream of a audio stream. And then without using a professional tool such as Adobe Premiere, you cannot take a hard word out, or you might have made too many uhs or ums, or you might have made a grammatical mistake, or you might have a exotic accent. How could you fix that easily? And this is the solution that I can fix mistakes like this in the editing tool. In this version, it transcribes what I spoke. You can delete, even insert. You can easily fix mistakes like this in the editing tool. So editing audio became as easy as editing text, which relieved the presenter pressure a lot. And when there is a transcription error, you can simply edit it by typing it over. But after deploying this tool, we realized that there's a more complicated problem than the functional aspect of asynchronous instruction, like production and consumption of the media. The issue is that people tend to feel uncomfortable when they're recording the voice because they don't like to hear their own voice, which is true for everybody, I think. So there was one issue, and the other issue is that some people didn't like the lack of the professionalism in their voice in a more formal setting. And we come up with a solution for other idea. What if we can use somebody else's voice, which is machine's voice, synthesized voice? So here's the demo of our system.
So my parents live in the city.
This is the original recorded audio.
The texting with them is very bare bones. It's like if we've been trying to call, my mom will text saying like, out to dinner, call you when I get back, or something like that.
And this is purely machine synthesized video, synthesized audio.
So my parents live in the city with my parents. All the texting with them is very bare bones. It's like if we've been trying to call my mom, we'll text saying like out to dinner, call you when I get back, or something like that.
Right. So this is what happened if you just synthesize audio based on what you have spoken, only the content. So this result put us in the question, like why you're using voice from the first place if you're not using the richness of the voice, right? because people use voice for delivering rich nuances in emotion, right? So we decided to retain some of the richness, such as pause timing, to a synthesized audio.
So my parents live in the city. With my parents all, the texting with them is very bare bones. It's like if we've been trying to call, my mom will text saying like, out to dinner, call you when I get back, or something like that.
So it feels more natural and more rhythmic, more personal, because it retained all the pause timing from the original audio and then transferred it to a synthesized audio. Then we can think about advanced version of this kind of system that detect emotions such as accent, inflection, and then transfer that into the synthesized audio so that it can feel more richer. So this is what I am trying to do with my research team right now. Now getting back to the AR/VR issue. Yes, I brought up this issue of asynchronous collaboration in AR/VR, and there's going to be the same level of challenge. If you record your performance in AR/VR setting by manipulating 3D environments, recording your voices in different places in the campus or 3D environments, then how would you navigate those contents effectively? How would you edit and alter those contents effectively? Or how do you reduce your psychological or mental pressure that you don't want to present yourself as is, and you want to present yourself better to the other people, right? Especially in AR/VR, if you record yourself as is, even in the small details of your bodily gesture, facial motion, it's gonna feel so uncomfortable for the presenter. How would you modulate those? How do you remedy those issues? That's an interesting research question. So, while working on that, I want to give you one example of how such asynchronous collaboration system can be useful in real AR/VR application setting. So I created a simple storyboard. It's a setting where AR/VR can be used in a game studio because 3D interaction matters a lot when 3D contents are there. You want to manipulate them as is in 3D. And in a gaming studio like this, there are usually social hierarchy, as I mentioned. There are game producer, and there are level designer, like game map designer, or actually manipulating 3D contents. And the game designer should report to the game director, game producer. So one created a game battlefield scene using 3D modeling tool, and then one is questioning, how can I get this 3D content reviewed by my boss? Then you can think about different type of the communication technology. Maybe you can sit one by one, side by side, and do the face-to-face conversation to discuss about, hey, you should move that to there, you should move that to there. Right? Or because face-to-face interaction is not always available in the business setting, you may want to do video chat. Then the issue is that in the video chat, it is really harder to point at where you're talking about. And also, you can use your bodily gesture to express your emotion, your sentiment, right? What about email? You can deliver the detailed messages in email, but it is harder to refer to a 3D contents by sending email message. Maybe using asynchronous message, the reviewer, the producer can get into the field and then record different messages around the game map and even manipulating the contents so that a game mapper can edit the message based on the recorded message, just like Google Doc and the comments, right? So I am telling you about future of the email, where you can record your richer interaction modality and then send it to somebody else. I'm talking about future of the Google Doc, where you can share a 3D contents and then create a comment over different parts of those contents. All right. So that is the end of my talk. And to summarize my talk, I talked about There are different perspectives on AR/VR from human-computer interaction research, which is framed by 3 different types of the waves. And the first and second waves seem to be have been well covered in VR/AR research, but maybe thinking about real work context and collaboration has some rough edge in traditional AR/VR field. I also introduced the importance of a transparency, well exemplified by my previous work on ebook application, and also importance of use of asynchronous collaboration and design issues and challenges. That's all. Thank you.